Okay, welcome you all to our first lecture, Big Data Analytics. And the course code is CSE761. And we will start our class from next class 6:30 p.m. up to 9:10 p.m. So this is the first lecture. So in this lecture, we will discuss about the course outline. And then after discussion of the course outline, we will discuss about the basics of big data, why it is necessary, and also the examples of big data processing, specifically the applications of that. So I think many of you already familiar with the term the big data. So this term describe that. That means big data means specifically a large volume of data. So when we think about the large volume of data, it can be structured or it can be unstructured data. So what's the structured data? Structured data, that means if we have the data and that data is produced based on some structure, or we can say we can develop those data or store those data based on some structure. So that usually we call the structured data sources or structured data. Like in our RDBMS, or we can say relational database management systems, usually we follow a structure to store those data, and therefore the definite structure we can maybe call also or retrieve to retrieve this data. So that is our structured data. And also we have some unstructured data. That means maybe we have the data, but those data are not stored in a structured manner. So that is our unstructured data. Like we can say the Twitter post or a document post. So those are unstructured data. We have also the semi-structured, like the JSON and XML data. Those are also semi-structured data. So in this term, there is a large volume of data. It can be structured, it can be semi-structured, or it can be unstructured. But not only the volume of data. Usually in big data, we can say that we have 5 V's in big data. Total 5 V's in big data. The first thing is maybe with respect to volume, maybe the terabyte, petabyte amount of data you have. And also that your data dimension is very high. Maybe we can say your data dimension is 1 million dimensions of data, 10 millions of dimensions of data, or maybe like we can think about that is that 10 million, and then maybe 5 million, and then maybe 6 million, and then again 2 millions. So this can be just a data volume, data dimension. Okay. So based on the dimension, based on the volume of data, we can say that this is the volume of big data. The next thing is variety. That means data can be generated from variety of sources, or we can say the heterogeneous sources of data. So that is our variety of data. It can be different types of data, like data can be numeric values, or it can be audio data, it can be the text data, it can be like the image data, so sensor data, that is the signal values. So there are variety types of data. So if we need to deal with those variety types of data, that means that is also one of the concern of big data. Then next, the velocity. Okay, the data velocity. The velocity, it means the incoming data. Maybe we can say at a time the amount of data is low, but you can see that is the speed of coming of data is high, like 12 petabytes per hour. So that means huge amount of data with respect to the velocity. And then in our big data, we have also concern about the veracity. Okay, veracity. That means uh, a data will be valuable if we consider about, that is the veracity. Veracity means the error free, or we can say that it is not only about the error free, but we can say that there is the bias free also. So if the data is bias free or accurate, error free, reliable, consistent, so those are concerned about the veracity of a big data. And then finally, the value of a big data, it means uh, so maybe we have big amount of data, but it needs to generate some value. It needs to add some value uh, for the industry, for the company, or maybe for the people also. So that is also another view of big data. So these 5 V's usually we consider as the 5 V's of big data. So if we have these properties or maybe any of the properties, then usually we consider those are our uh, big data. So this course we will discuss about, that is the big data introduction. That means what are the sources of big data and what can be called as big data. And then we will discuss about the big data modeling and management techniques. That is the what are the procedure usually we follow in big data modeling and how to manage those big data. And then uh, the data integration and processing also. That means if we have the big data from different sources, then how can we integrate those data to make it valuable? So that is the big data integration, and also the processing or analytics part. And also the machine learning with big data, we will discuss about that. That is, there are several machine learning algorithms specifically to deal with the big data. So we will cover those algorithms. And this part, that is the machine learning with big data. So we will cover several machine learning algorithms specifically for dealing with the big data. Uh, like if we can say that, okay, maybe we have the data, but we can maybe apply some form of clustering algorithm. Like maybe we can say the well-known clustering algorithms are k-means algorithm, k-midwives algorithm. Uh, but again, how to deal with the big data if we want to apply the k-means algorithm? Specifically, there are some specialized algorithm machine learning, those we need to consider for big data handling. Okay, so those machine learning algorithms we will discuss in this course. And then also the graph analytics, there are various sources of big data. We need to um, pre-process those data. Specifically, we need to that is produce uh, the some form of a structured form, specifically the graph structure. After converting those data or transforming those data into graph structure, we can apply some of the machine learning algorithms also. So those are called the graph analytics of big data. So we will discuss also the graph analytics of big data in this course. And finally, the big data projects. Okay, that means we will develop a project that is the big data projects. So these are our the kind of the course structures, okay, we need to follow. And we have some course outcomes, like they explain the background of uh, a big data analytics and tools. Okay, the spelling mistake is there. Big data analysis tools, and then maybe analyze and describe the big data ecosystems. And in course outcome 3, we will apply machine learning, cloud computing, and distributed computing in big data applications. uh, so you'll gather the knowledge of knowledge and understanding of reports generated by those applications. Okay, and we have also that is the in CO, what are the contents? It will cover the CO1 and contents for CO2, and maybe contents for CO3 and CO4. We have uh, that is the course outcome 1. It will cover these two contents, specifically the introduction to big data and sources of big data, and introducing a big data analysis tools. And then the 5 V's we will discuss in details about those. So those will cover the CO1, and Big data file systems, advantage, disadvantage, and different types of file handling with big data. It will cover the CO2 and also data preparation, summarization, visualization. Those are also covered, that is the CO2. And CO3, from CO3, that is the streaming data characterization, capturing, storing, and analysis data stream, and data analysis tools cover the CO3. And big data management platforms like Hadoop, MapReduce, Spark, Flume, Kafka, and HBase. So those topics we will discuss under the CO3. And another CO3 is from the big data analysis, specifically in distributed systems. And finally, CO4 will cover the big data project. The contents or lecture topics we will discuss about like this way. In week 1, we will discuss the big data and big data mining, specifically the association rule mining. And then we will discuss about the big data programming model like the MapReduce. And then big data clustering, we will discuss the hierarchical clustering approaches, BFR and CURE. Those are some specific algorithms for big data clustering. And the big data dimension reduction algorithms we will discuss in week 4. And then large scale machine learning algorithms, specifically classification algorithms, we will cover in week 5. And week 6, we will discuss about the regression algorithms. Those are the large scale machine learning or regression to deal with big data. And then the midterm exam, and after that we will discuss about the recommendation systems, specifically for the uh, 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 big data recommendation systems. And then finding the similar items, specifically the association rule. Those this will be the extended version of that, finding the similar items. And then we will discuss the big data management platform, that is different platforms like Hadoop and Spark. Then we will discuss about the social network mining, so specifically the graph mining algorithms we will discuss on that. And then we will discuss about the link analysis. There are several link analysis approaches for the big data problem. We will discuss about that. Though here it is after that we will discuss about the mining the big data streams. Specifically, we can say the continuous data streams are generated in case of the big data, but we need to deal with those continuous data streams. And how can we deal with those continuous systems? What are the algorithms for that? We will discuss in week 13. And after that, maybe the final exam. You can see that is the course assessment methods. These are the course assessment methods we will apply or utilize. That is the class attendance or participation in the class. It will carry 5% of the marks, and then maybe assignments. We will provide the assignments specifically theoretical assignment, and also some form of programming assignments also. So it will carry 20% of the marks. And then quiz, it will carry 10%, midterm exam 20%, presentation based on some big data research. It will carry 5% of the marks, and project and report will carry 15%. Finally, final exam, it will be just on 25% of the marks. So that's our course plan. So if you have any question or queries on our course plan, then you can ask. If you have any queries. No?
So will you get lecture slides or any other study material like that?
Lecture slides?
Yes, sir.
Yeah, we have the course repository for that. So here is the Google Drive. I think you need to visit this drive for the course materials. Okay, specifically the lectures and the some of the reference books are there. So I will share this course outline. I think you will get that. And we have a Discord channel for the communication. Okay. And also this is our Google Classroom code. Please note this code to join our Google Classroom. So in our Google Classroom, we have I have already uploaded it. Okay, so if you can join here, if you join here, then you will get this course outline.
Sir, I have a question.
Yes, please.
Sir, about the assignments, what kind of assignments can we expect from this course?
Um, Specifically, this course is all about some algorithms. Okay, the different algorithms we will learn. Specifically, I will focus on big data algorithms. Okay. Okay. That's why the algorithm means we need to implement those algorithms. Some of the assignments I will assign, and on that assignments you need to implement those algorithms.
So will it be similar to the machine learning assignments on data camp?
I didn't think about it. Okay, I can think about that is if if I can find the data camp, it has also course on big data. If I think those are maybe useful for this course, then I will assign.
Sir, can you kindly share us the timeline of the presentations and the assignments when we will be given those?
Initially, I don't have the timeline at this stage or at this moment.
Okay.
So as it is mentioned that is the presentation here, I mean, after the midterm, I think you will get those after the midterm.
Okay, sir. So the assignments will be before midterm, I guess?
Yeah.
Okay, sir. So if it's written quizzes, so I hope there will be multiple quizzes and you will be considering the
Actually,
test.
the course we have machine learning and that is big data. There are several algorithms. Okay, each and every week we will learn several algorithms maybe. Then taking too much quizzes, it means that is reducing the number of algorithms.
Classes.
Yeah,
Yeah.
that's why I don't want to take many quizzes. Just only one quiz. If necessary, I will take two. That's all.
Okay, sir. Okay, sir. Thank you so much.
So any other queries and your suggestion? Okay, so these are the reference books. I have already uploaded the soft copy of those reference books in our repository. You can download those.
Sir, I can't join the Google Classroom. Can you please write the code in text?
You cannot join?
No, sir, I think I'm making some kind of mistake. It would be easier if I could copy paste the code.
Okay, use it please.
But did you invite us in the Google Classroom or
No, you have to use this code to join our Google Classroom. Okay, there is invitation link also, but I think I just copy and paste here. Anyone face difficulties to join our Google Classroom? Still, I think no. Okay, I think then we can continue our lecture. Okay, why can big data help? Specifically, we can maybe get the data from different sources. Okay, like maybe we can get the data from sensors, and maybe we can get data from this organization, and maybe we can get the data from our from the people. So data can be generated from the several uh, several sources, sensors, organization, people. uh, and the big data, this method or the big data methods, it will help us to integrate the data from the people and organization and sensors. Why integration is a problem? Because uh, the generated data are the big data. That means maybe based on the volume, or maybe based on the variety, or based on the speed or velocity. Okay. So that's why it's an integration is a problem. That is, data integration is a problem. Even though if we can think about like the counting the values, some values, okay, counting some values. In case of the big data, it's a problem, uh, because maybe you want to count the data from different sources, and then those sources are the volume of the sources are maybe in terabyte of data. Then just only you can apply the counting approach, like that is uh, first the frequency of that. This counting is also a big problem or big issue. Then how can we deal with that? That means you need to have some integration method for that. Uh, like maybe from the sensors, we can see there is the MIoT sensor, the medical IoT sensor data. There are huge amount of data generated from the medical IoT sensors. For maybe for any patients, you need to monitor the health status using different types of sensors, and then you need to observe those data continuously. So that means if those data just continuously is stored in a in some files, then there is the huge amount of data maybe you will get per day. And then the sensor data, we can say more sensors, more places of data. Then we need to think about the storage and analysis. So the think about that is storage. How can we store those data? Can we store just only within a single place, or we can just like maybe we can just silo up a data? Then how can we connect those? And then we need to think about the analysis of the data. That is, how can we analyze those data? How can we find out the features to train our model? So that means even though we can consider about that is the medical sensor data, that is MIoT data, then for based on our volume and based on our the speed of that is the coming data, we can consider those data as a big data. And there are thousands of fitness devices and fitness industries are there, and day by day we can see that those devices are increased, and use of those devices are also increased. So maybe we can say that is at this moment they can generate maybe 12 petabytes. In future maybe they will generate hundreds of petabytes of data, and the using of those devices are nowadays the very common, like maybe the data generated by this gadget, it is like maybe 2 to 5 gigabyte per day. So even though just you can analyze the data from this that is the wristband, per day it will generate 2 to 5 gigabyte. How about that is 1 month? How about 1 year? So then if we want to find out like maybe from this the gadget, we can find out that from this sensor value, we can find out the variability of our heart rate, that is the heart rate variability. How can analyze those heart rate variability from maybe the petabytes amount of data, just for maybe 1 month or maybe 2 months or 3 months of data? Just a single sensor here. But we can see that if we can analyze those, then maybe uh, it can save health, or maybe it can save also the healthcare cost, because early symptoms maybe of heart disease we can recognize. Okay, so that means it has the value to analyze those data, but the problem is how can we deal with those big data, specifically based on some storage mechanism and also based on our uh, analytics. Again, think about our organization data, because we can see that is I have mentioned here three types of data, like the sensor data and then maybe organizations data. There are several organizations, and like maybe we can say that is the some organization will store the people's genomes, and based on the genome sequence and based on maybe the sensor data, you want to find out the precision medicine for that. So on that case, you need to store maybe the every people's data, and then we can say number of peoples of this world or maybe for a country is huge, and their genome sequence, if we want to maybe just store the genome sequence, and then you need to transcript it, uh, and after the transcription maybe you need to translate it, and then maybe you need to find out the protein expression using some form of biological function to annotate that data, to annotate the protein function, and then maybe after that you can use that one for analytics for the precision medicine. So this organization store the humans data. Then how can this organization store this huge amount of there is the DNA data, their transcription data, their translation data, and then protein expression sequence. And then again, we need to find out these expressions, that there is protein expressions, that are different features you can analyze based on the expression. Then if the data volume is huge, then how can we apply and how can we create the value from the data? So that means we need to apply some form of scientific method for that. And maybe after that, we need to create some knowledge base. Maybe you need to create some knowledge base in some specific format also. Like you can think about the graph knowledge base, or you can think about some maybe propositional logic based knowledge base, or we can think about like maybe semantic structure knowledge base knowledge you need to extract from the data. Then again, then you need the analytics there. Okay, so that means we need to know how to deal with that. And then think about our people data also. There are maybe several mobile health apps, several sensors are also in mobile devices. So those sensor data you can store again. And not only the sensor data, people also use their that is the smartphones, or maybe you can say tabs, for various purposes, like maybe the posting uh, in media, or you can say the Facebook or Twitter. Okay, those posts are also, there is huge amount of posts per day. So that's why if we think about that is the people data, uh, there are huge amount of posts each and every day for a single user. And if we want to study, maybe if we want to find out the people's behavior, and based on the behavior you want to recommend some maybe some sort of medicine, some sort of remedy, and some sort of behavior analysis you want to do on that social media post, then again this is also huge amount of data per day. Okay, so the integration is necessary. Then after integration, maybe we need to think about the personalization for the precision. Okay, that means think about the integration of sensor data, and then maybe you can say people data and also our organization data. This after that integration, we need to think about the personalization, the personalization, personalized medicine, personalized healthcare. Okay, so that means in this domain, specifically to deal with those huge amount of data is necessary, and the in case of the integration, in case of the storage, and also in case of analytics. Uh, Now I think it's better if we can think about like an example for that. Okay, I think most of you already know about the association rule mining. Specifically, we also call it like um, we also call it the market basket analysis. So think about a data set that is we have the small amount, a small data set. In that small data set, we can easily think about that is counting the frequency of beef in the, counting the frequency of cheese, counting the frequency of chicken and clothes together. So we can easily count that. But how about that is if the data set is big, or we can say we need to maybe count the frequencies of those items uh, from large volume of data. Maybe we can say one machine can have like maybe 3 petabytes, another machines can have like maybe the 10 petabytes, another machine can have maybe there is 2 petabytes of data. Those transactions, that means we can say these transactions, we can think about like there is several transactions uh, in several machines. Maybe in 2 petabytes of data we have millions of transactions are there, and in another 10 petabytes of data there also have like uh, there is 2 million transactions that are there. Okay, now the problem is we need to count the frequency. Okay, count the frequency, that means to find out the frequent item set. Like if we have a small amount of data, usually in association rule mining, what usually we do, maybe we want to find out the frequent item set, like that is chicken, clothes and milks. How many times these three items purchased together. So we can see that for the small amount of transactions, we can see that we can check the transaction one. Okay, no, chicken, clothes and milk are not purchased together in transaction one. Then transaction two, no. Transaction three, no. Transaction four, no. Transaction five, chicken, clothes and milk, yes, one time. Then maybe in transaction five, okay, transaction five, we can see that these three items we can get together. Similarly, maybe for the transaction number 6, chicken, clothes and milk together. And in transaction 7, chicken, milk and clothes also purchased together. So that means we can see there is uh, three, three out of 7 transactions. Those 3 items we can maybe we can get together. So the frequent item set, specifically we can call it frequent item set if we think about our uh, that is pass this minimum support threshold. So whether this one is minimum, if we consider what minimum support threshold is 30, uh, then we can see this one is 30, that means 0.3. Okay, that is we can say 0.3 per 0.3. So we can see that 3 by 7. And we can see that that is the 3 by 7 equal 0.428. Okay, so this is actually the support is 0.428. Which one is greater than, that is minimum support threshold, that is the 0.3. So we can consider this one as a frequent item set on that case. Okay, consider this one as a frequent item set. So that means we need to count how many times chicken appeared in our data set, how many times clothes appeared in our data set, how many times milk appeared in our data set, and how many times maybe we will get all these elements together, chicken, clothes and milk. So here counting is necessary. But if the data set is huge, or we can say we got the data in different machines, then how can we that is the find out the total count? And for that, maybe there are several approaches in big data processing. One approach is called that the MapReduce. MapReduce is one of the approaches we can apply uh, the MapReduce procedure to find out that is the count of those values. Okay, what's the procedure for that? Just for an example, if we can see that is the we have the big document, and on that big document, maybe you can say this is the machine one, and the part of the document is here, or you can say we have the uh, we have the big database, and on the database the that database part of the database is here in machine one, and part of another machine here is the another machine. Okay, that means we have several machines, and that document is divided into several machines, like 3, 4, 5, here 6 and 7. Okay, 7 machines we have. Now what we have to do in the map structure, what it will do, it will read the input and produce a set of key value pairs. We will detail discuss about this map reduce process in later another lecture, but we can see that is the key value pairs. It will find out the key value pairs. And what does it mean? We can see, maybe we can say in that big document, the machine one, we have this data. So this is in our M, that is machine one. So in that machine one, what it will do, it will find out each and every word, like the crew, the here is off and the space. Okay, so that means we can see from here we will get maybe the, and then crew one, and again off one, then the one, like this way. Okay, so this is called the key and value. So key is here the, and the value is just one. So key value pairs. Okay, so here similarly for this part, or you can say maybe this part of the document is also huge document. This part, it will reside on M2, that is another machine. And from the key from the map operation, it will find out there is maybe here is off is one time, and then maybe the is one time. Then for each and every word, it will count like in key value pairs. Similarly, for this part, maybe this is our M3 and this is our M4, like this way. Then for each and every machines, it will find out the word, each and every word, and then the value is 1. Okay, this is called the mapping. So after mapping, what it will do, it will perform the group by key. So that means they collect all pairs with the same key. So like here, we can see maybe the crew is here. From this machine, here is the crew. And we can see that the here is the, and here is also the. Okay, so group by, that is collect all pairs with the same key. So it will also produce like this way. That is crew, and then a space, then the. Okay, so we will get this using the group by commands. And after that, we will apply the reduce. So in this reduce, it collect all values belongs to the key and the output. Like we can see here the crew, how many times you can see 2 times. So here is the 2. Then a space may be the 1 time, and the 3 times. Okay, so it will combine the outputs from each and every machine. Finally, we will get this data. So this is one approach that is called, here is the word counting example. So that means we can see that is key in map procedures. We have several machines. Then using the map procedure, we can see here is key and the corresponding value key 2 and corresponding. That means we can say here is the here is the also same, and the value here is the 1, here is 1, and maybe this is another key like a space, the value is just 1. And in this machine maybe we can say we didn't get anything, and M3 maybe you can say that here the key 1, that means the same thing. This is the K1, the key 1, maybe this one is also the, and the value is this. Okay, in this way from the several machines we will get several outputs. Now what we have to do, we have to apply the group by. Then in group by case we can see here this one is K1, this one is K1, and here is also K1. So the K1, that is the V, here is the V, and here is the V. So this is the group by those keywords. Okay, so group by, and after that we will apply the reduce operation. The reduce operation, like here we will get the total count, that is Q, how many times or how many instances are there. So here we can see there is the K1. So here it will be the K1 with 3, there is the 3V. Okay, 1 2 3 4 4 V's. Maybe we have another one also here, that is the 4V. Similarly we can say K2 how many times, 1 1. Okay, so K2 it is in 1 time, like this way. So that means now we can count, that is maybe how many times the appeared in our data set, how many times the space appeared in our data set. Okay, like this way. So this method is called the map reduce. We will discuss more about it in our another lecture. What is that? Okay, so that means if we want to count the frequency of each and every item, like beef how many times, chicken how many times, milk how many times, uh, then we have to apply this type of approach. Okay, because we cannot deal with just only the data with a single machine. We have to think about the the big data set, and those data will reside in multiple machines maybe. uh, Uh, so I think most of you already know about our the association rule mining approach. Is it true? Uh, uh, Anyone here didn't study the association rule mining?
Yes, sir. I'm not familiar with that.
Yes, sir, me too.
Uh, okay. Then in our next class, maybe we can start discussion a little bit about that, and after that maybe we will discuss how we can find out the frequent item sets in case of the big data. I have just maybe discuss an example here. Okay, map reduce. As I written in this course, actually we need to know the machine learning and data science maybe before taking the big data. Okay, otherwise maybe many algorithms of machine learning I will discuss about those, but we can I will assume that you already know those algorithms.
Yes, sir. Put those, keywords are something that we made, that is a prerequisite to the algorithm knowledge.
Yeah,
Then
yeah,
we
yeah,
can research on ourselves.
yeah. Oh, yeah. Uh, I have also the machine learning course, and the course materials are there. I think you can go through those, no problem.
Yeah, sir. Did you, share the slides and the course materials in the classroom? Like
Mm,
we can find it there, right?
no, for the machine learning is no. Okay, I will share, no problem.
Okay.
If
Thank you,
someone
sir.
is here, not maybe already done the machine learning course, then you can go through.
Yeah. Thank you, sir.
Okay. So either machine learning or data science. If you already have done, then maybe this course will be beneficiary for you. Okay. Otherwise, maybe it's difficult for me to go with you, specifically because the knowledge of some previous machine learning algorithms is necessary. Okay. So any question you have?
No, sir.
Sir, will the recording be uploaded in the Google Drive?
Yeah, I will upload the record.
Okay, sir.
Okay, so I think I want to stop here now for today's class. Next class I will start from our association rule mining and how can we deal with the association rule mining, or we can say how can we find out the frequent item sets specifically in case of the big data.
Yes, sir.
Okay, thanks all of you for joining this session. I'm sorry for the delay.
No
Because this is the
problem, sir.
first class,
Thanks.
I need to manage something, but I didn't get time today specifically for some reason. Uh, okay, no problem. Okay, thank you. Thank you for very much for attending this session.
Sir,
Yes.
will there be any attendance of today's class?
Yes, I need to take the attendance. So attendance, please. I'll just call the serial number, okay? Serial number 1, attendance, please.
Yes, sir.
2,
Present, sir.
স্যার
3,
স্ক্রিন দেখা যাচ্ছে না।
স্ক্রিন দেখা যাচ্ছে না, কি প্রবলেম?
স্যার আমরা দেখতে পাচ্ছি, মেবি এটা ওনার প্রবলেম, ওনার সাইড থেকে।
আচ্ছা, ওকে।
আমরা দেখতে পাচ্ছি।
স্যার জুম করলে স্ক্রিন দেখা যায় না, মেবি জুম আউট করতে হবে।
জুম করা নাই তো।
মানে আমাদের সাইড থেকে
ও,
স্টুডেন্টস ভিউ।
Okay, serial number 3,
Present, sir.
4,
Yes, sir.
5,
Yes, sir.
6,
Present, sir.
7, 8,
Sir, 7. Sorry.
7, 8, 9, 9, 10,
Present, sir.
11, 12,
Present, sir.
13, 14,
Present, sir.
15,
Present, sir.
16,
Present, sir. Speaking, sir.
17,
Present, sir.
18, 18, 19, 20,
Yes, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24, 25,
Present, sir.
26,
Yes, sir.
27, 28,
Yes, sir.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Yes, sir.
33, 34, 35,
Yes, sir.
36,
Present, sir.
37, 38,
Present, sir.
39,